Okay.
Hi everyone. In previous video lectures, we've been seeing about various rules to reduce the block diagram and how to determine the transfer function. So now we'll see about a simple problem by applying the rules how to determine the transfer function for a simple block diagram. So this is a simple block diagram it is given. So what we need to do, we need to reduce this block diagram and we need to obtain the transfer function. Your transfer function is just nothing but your transform of your output divided by an input, right? So here output is nothing but your C and your input is R. So you need to find a transfer function which is nothing but C by R. So by applying a block diagram rules, by reducing this block diagram, you need to obtain the transfer function, right? So first what you need to do, first you need to analyze the what is the given problem and what are the blocks and how the blocks are located. So now if you are seeing this block, so what you can see, so the first thing we can see like this block's being taken feedback, right? But it is not in an exactly feedback because you have some takeoff point here. So you couldn't consider this as a feedback loop and you should not apply like elimination of the feedback here. So what you need to do first is then you need to move this takeoff point to this ahead this block. So what you have to do, so you have to move this takeoff point to here, right? So when you have moved this takeoff point, what you have to do, so you are moving this takeoff point to this, so ahead the block, so you are moving this branch point, takeoff point which is nothing but a branch point. So you need to include a block in the branch point. So this is your branch, right? So you need to include some block in a branch which is the value, the reverse of the value which is to which you are moving it, right? So what happens, so you have, so this is the summing point you have and this is the block which is G1, right? And what you are doing, you are moving this takeoff point to here, right? So your takeoff point came here, right? So when you are moving in takeoff point, what you have to do, you have to add the block. The value of the block will be reciprocal of this value, so which is nothing but 1 by G1, right? And already you have the block nothing but what is that? G3, right? G3 you have, and here it is the block G2. So you have the block G2. And you have the summing point here. So this is plus and here also it is plus. So put a C. Right, and one more, the feedback which is here, which is H1. So which is H1. So here negative and here it is positive. This is the input C and here output. So what we have done here, so just we have moved this takeoff point to the ahead the block G1. So I have moved this takeoff point, the takeoff point being present here, right? I have moved here. So whenever I am moving in branch point or takeoff point, I need to include a block which will be need to include the block. So if it is a summing point or if it is a takeoff point, I need to add the value, the reciprocal of the value. So G1. So it is the reverse of G1, 1 by G1. So I have included the block 1 by G1 into the block which is already present in the branch G3 and it is joining in a summing point, right? So this remaining block is as such. So the first rule what we have applied here is the rule, the step 1, moving a takeoff point, ahead the block, which block? The block which is G1, right? Ahead the block G1. So the first thing you have moved this point and you got some block diagram, right? So your next step is like, next step you have to analyze what is your, what will be your next you can reduce. So you can see this G1 and H1 which is sorry feedback, right? So this is the forward path and this is your reverse path. So this G1 and H1 are in feedback. So now what you can do, you can eliminate this feedback and here when you are seeing this next part, this block 1 by G1 block and G3 which are in series, right? So you can, when the blocks are in series, you can apply your first rule and you can multiply the values of both the blocks and you can make it as a single block, right? So your next step what you can do, you can eliminate the feedback. Eliminate the feedback path or the feedback loop, something like that, right? Eliminate the feedback loop. So on eliminating, so which one? This is your feedback, right? This whole thing is your feedback. Including this summing point you have to take. You need not to eliminate the summing point, right? So including summing point you have to take. So this is your feedback. So this is your feedback. So you need to eliminate this one. So when you are applying the rule, what you will have? So on eliminating this feedback, you will get a single block. The block value which is upper value, which is nothing but G1 divided by 1 plus upper block value G1 into your feedback value H1, right? G1 divided by 1 plus G1 into H1 you will have, right? So next thing what? So I have reduced this feedback into one single block, which is the value of the block is G1 divided by 1 plus G1 into H1. So next thing is like this block will be as such, right? The block which is G2, and you have some summing point here, and in this block it is 1 by G1. Your next block will be, next block is G3, right? So the output is nothing but R. Here also is plus, here also is plus. This is in forward path, this is in forward path. Your input is nothing but R, right? So your next step, what you can apply here? Your next step is your step 3. What you can apply here? So now the block G1, 1 by G1 and G3 are in series and cascade, right? The blocks 1 by G1 and G3 are in cascade, right? Cascade, which is nothing but both are in series. So you can club it into a single block. So how you can club? So this block will be as such, which is nothing but G1 divided by 1 plus G1 into H1, right? And this G2 will be as such, and you have some summing point here, right? This block being, both the block being reduced as a single block. Single block, what is the value of that block? It is a multiplication of both things, right? So 1 by G1 into G3, right? So this is plus, and you have your output which is nothing but R. So now you have changed this, you have combined this both the block into one single block. The value which is nothing but G3 divided by G1. G3 divided by G1. So what you have done is like you have combined this two blocks as a single block. So 1 by G1 is one block and another block is G3. So you have combined this block into one single block which is G3 divided by G1, right? Your next step is, so your next step is 4. So now we can see like these two blocks are in how? So these both the blocks are in something is like in parallel, right? This is also in forward direction and this is also forward direction, which is meeting at a summing point, one summing point. So this both the blocks are in parallel. So now what you can do? You can simplify this. You can reduce this both the block into one single block. So you can write it like the blocks G3 by G1 and G2 are in parallel. So by reducing what you will get? By reducing, so your initial reduced block will be as such, nothing but G1 divided by 1 plus G1 into H1, right? So you can, so when your both the blocks are in parallel, what you can do? You can sum up the values of both the values, right? So when you are summing up, what you will have? So this block value is nothing but G3 divided by G1, right? Plus G2 you have, G2, right? You have to add. So here also plus, here also plus. In case if you have here negative, you need to put here minus. So but we have only positive, so I have included plus value, right? So this is your R. So this is your next value. So what you have done is like your next step, you have reduced this block into one single block. So when your block G3 by G1 and G2 are in parallel, so I have reduced this parallel block into one single block G3 by G1 plus G2. So and what the simplification you can make? You can take an LCM here. So when you are taking an LCM, what you will have? So when you are taking an LCM, so you have like G3 plus G1 G2 divided by G1 you will have. So this will be your block of this value, right? So your next step will be, so now you see this block and this block, both the blocks are in both the blocks are in series, right? Cascade. So when your blocks are in cascade, what you can do? You can just multiply the values of both the block, right? This is R, sorry, this is C. So your next step will be, you can multiply the so your step 5. So your last step. So block which blocks the block G1 1 plus G1 H1, and your next block is G3 plus G1 G2 divided by G1. Both the blocks are in how? Both the blocks are in series or cascade. Series or cascade. So when both are in series or cascade, what we can do? We can make it as a single block by multiplying the values of both the blocks. So I can make it as a single block. So I make it as a single block by multiplying the value nothing but G1 divided by 1 plus G1 H1, right, into next block of G3 plus G1 G2 divided by G1, right. So your output is nothing but C, your input is nothing but R. So this is your transfer function. The values which is inside this block is your transfer function, right. So now what you can do, you can cancel this thing. G1 and G2 get cancelled, so you will have your output as, so you will have this value which is nothing but G3 plus G1 G2 divided by 1 plus G1 and H1. So this will be your transfer function. So this will be your transfer function. So your final thing will be like, so the final thing will be like, you have reduced the block diagram with, whole block diagram with G3, G1, G2 divided by 1 plus G1, H1. So this is your C and this is your R. So this is your final value. So your transfer function, the value of transfer function, which is nothing but your C by R, right? If you need to find your value C by R, your C by R, which is nothing but G3 plus G1, G2 divided by 1 plus G1 and H1. So this is how you need to simplify an block diagram. You need to apply the rules to simplify a given block diagram, and you need to obtain a transfer function.